Okay, good morning, class. Let's talk about the centroid of a composite body. Okay, this is chapter 6. So ideally, a centroid typically, it just represents a geometric center of a body. It's almost like a center of gravity, so to speak. Okay, so this point, this centroid, right, um, it coincides with the center of gravity only if the material composing the structure is uniform and is homogeneous. Okay. Therefore, these structures are, in our case, because we're looking at composite bodies, right, or composite structures, they comprise of various shapes such as triangles, rectangles, and semicircles, which you'll see in the later slides. Okay. So for the common shapes we're going to use for our particular case, in terms of centroids, we're looking at composite bodies. They typically have um, a uniform or homogeneous shape. So we're looking at like a rectangle, we're looking at a triangle, okay, in this case, and certain things one should know about the rectangle is we have to understand what is the area and the centroid about the y-axis. So as you can see here, this would be the centroid of this rectangle, and the centroid is denoted by this y bar here, and it's being calculated by taking h and divide that by 2. Again, this is our h here. This is our I'm sorry, it's our B. So whenever you want to calculate the centroid, which is y bar, is nothing more than h divided by 2. Okay? So we'll talk about C and D later on, but for right now, I'm just focusing on A and B. Okay? So again, for a composite body, in particular this rectangular shape, if you want to be able to find the centroid, our centroid is denoted from the x-axis. Now this is our x-axis right here, right? And this is our y-axis right here. So if you want to locate the y bar, as we call it, and that's going to be a distance from the x-axis to the centroid. It's nothing more than a distance. It's going to be the height divided by 2, okay? And that's what you see right here, okay? Now we look at a triangle, okay? Another composite body. You want to, again, we're just looking at A and B. Okay, so for us to calculate the centroid, again, the centroid about the x-axis is nothing more than just a distance. It's a distance from the x-axis to where that center of gravity is, or that center of mass is. In particular, that's that centroid, where it's located. Okay, then that's going to be y bar, and that y bar is calculated by taking the height and dividing it by 3. Okay, so this is your height right here, and you divide that by 3. Okay, so in other words, if you have a triangle here like this, oops, let me draw this a little bit larger so you can get the point what I'm trying to make here. So I have a triangle like this. From here to here is h. From here to here is going to be h over 3, right? Okay. So, in other words, if your h is 1, if your h happens to be 1, right, therefore it's going to be 1/3. Then from here to here is going to be 2/3. Okay, so just kind of keep that in mind, because you can have a triangle flipped and it could look like this. Okay, now mind you, your centroid from here to here, this flap piece right here, is only 1/3, or in this case, h over 3. So you may have to calculate from here to here. Okay, but if you know the whole height of the triangle, you could find different portions of that triangle. Okay, again, we'll come back and talk about this later. We'll come back and talk about this later. Okay, and here's an example of trying to find your centroid. for an isosceles triangle. Okay. Now going on to other shapes, we have here a half circle. Okay. And again, we're looking at A and we're looking at B. Okay. So we're given here what is the area of a half circle and what is the centroid about the x-axis. Okay. Again, centroid is nothing more than a distance from the x-axis. This is your x-axis right here. So distance from that centroid, that center point, all the way to the x-axis. That's known as your centroid, and that's denoted by y bar. Okay, and this is the formula right here for r, which is the radius, divided by 3 pi. Okay, now for a trapezoid, we're looking at we're actually looking at 3 different sides. You got B, you have A, and you have the H component. And again, if you want to find the centroid about the x-axis, this is your x-axis right here. Okay, it'll be this distance from the x-axis to the centroid. Okay, and that's denoted by our y right here. And this is our area for that particular centroid. And again, we'll talk about this later. We'll talk about the moment of inertia later. Okay. All right, let's jump into an example I have outlined here. So we have this geometric shape here. It's a composite, and it's made up of a rectangle, actually made up of 2 rectangles, right? Because you can break this up. This could be rectangle 1, and this could be rectangle 2. Okay? So, again, this is your reference line, which is your x-axis, as I've drawn all the way through here. This is your x-axis. And they've given us the dimensions for this particular composite. We call this a composite because it consists of 2 or more geometric shapes, and they're uniform, homogeneous. Okay? Now, I want to find y bar. That means that this is 1, this is 2. When you bring them together, they have a combined centroid, if that makes sense. They have a centroid that both of them adhere to when they're combined together. So for our geometric shape 1, okay, I just drew it out again, okay, just as I did here. I mean, just as it's seen here, and as a 2 by uh, as a 2 by 9, okay. And again, the centroid, this is C1, is going to be located, it's going to be h over 2, which is going to be 1 inches, equals our y bar 1. Okay. Now, for geometric shape 2, this component here, okay, as you look at the measurements, it's going to be a 6 by 3, right? Now, mind you, this geometric shape is being raised up by 2 inches, though. So in actual words, what I'm trying to say here is this piece, geometric shape 2, sits on top of geometric shape 1 by a distance of 2. Okay, so we cannot forget that part of the measurements. Okay, so our centroid is going to be located, again, for a rectangular shape. It's going to be h over 2. Our h is 6, so it's going to be 6 over 2 plus this 2 inches right here. Okay, and that's going to give us 5 inches, equals our y bar 2. Okay, now that we have y bar 1 and y bar 2, we can come here and then we can just set up a table whereby for our shape 1, the area is going to be 9 by 2, which is going to be 18 inches, right? Y, this typically means it's a counter, just saying y1. So this is shape 1, this is area 1. Y1 is going to be 1 inch, right? I don't have to put the inches here because I already put that in my table. Okay, and now the product of the area and the distance, which would give me a cubed, right? This is squared here, and squared. So this will give me 18 inches cubed. Now for geometric shape 2, I have 2 by 12, 2 by 6, which is 12. And then the y2 was 5, and that gives me 60. So now when I want to, next step I want to do is I want to be able to sum the area, which is going to be 30, right? You never do nothing to the distance. And then I want to sum the product of the area and the distance. So as I have a line here, here's the area, here's the distance, which is my y bar 1, y bar 2. And this column just typically um, holds on to the area, the product of the area and the distance. Okay, so I want to add these two up, and that's going to give me 78. Okay, so my total y bar, which is the total centroid, is going to be the summation of the area, the product of the area and the distance, divided by the summation of the area itself. That's going to give us 78 inches cubed divided by 30 inch squared. Okay, and when you put that in your calculator, you got 78 divided by 30. That gives you 2.6. Okay, inches equals your y bar. So this is your total centroid. So in other words, if I were to go back here and erase all of this, this right here is 2. Erase this part too. This would be 2.6 inches. Okay, let's look at another example. Okay, I have here this geometric shape here. Okay, and I've been given the different dimensions. Now, in this case, we have a void. So this is typically like a void, like a hollow space in that geometric shape. So one thing you can do is just outline the whole thing first, which I have right here. So let's pretend this is all one solid piece. Okay, this is all one solid piece, right? And this is going to be the void. So for the centroid 1, right, we have a dimension of 10 by 9. Okay, so again, if you want to find the centroid of a rectangle, it's going to be h over 2. In this case, it's going to be 10 over 2, which is going to be 5 inches. Okay, now come over here to the void part. This is the area that I'm looking at right here. I'm looking at this area right here. That's what I'm looking at right here. Initially, I looked at this whole area right here. Okay, now I'm looking at the hollow point, and that's 6 by 5, and that's going to be 6 divided by 2. Since it's a rectangle, it's going to be 3 inches. Okay, so in this case, I've had some of this filled out for you though, but to make things easier, just draw a table. You have your shape, you have your area, you have your distance, and it's the product of the area and the distance. Okay, so for shape 1, which is a solid, right, the area is going to be 10 by 9, which gives us 90. Okay, and then we have our distance. Central distance was 5 inches, which I have right here, and the product of the two will give me 450. Now go to the void now. Okay, and the area of that is going to be 30, but again, remember you put a negative 30 because it's a void. It's missing, right? The distance is just going to be 3, okay? And then we take the product of the two, is going to give you a negative 90, okay? And then we want to sum them up, sum the area up, which is 90 minus 30 gives us 60. We do nothing to the distance, and then 450 minus 90 is 360. So now your total y bar, your total centroidal distance is going to be the product of your area and your distance divided by the summation of the area itself. Okay, so this is the 360 inch cubed. Divide that by 60 inch squared. what I have, this is wrong here. This should be inch squared. Okay, and now we're going to get 6 inches equals your y bar. Okay, all right, so let me do one more. Let me do one more problem. Okay, so here's a trapezoid in a nutshell, but you have this component taken out. Okay, so what we can do again, we want to be able to locate the centroid about the x-axis. Okay, so we need to find this centroid. Okay, the distance from the centroid to the x-axis is denoted by y bar. Okay, and this is your reference line because everything is about the x-axis. Okay, so I just redrew the shape here, and what I did in the previous example, we have a trapezoid. So all I'm doing right this point right here is I am just drawing one whole trapezoid, and this is what you see right here. Okay, the height is 10, your A is 10, your B is 14, and then so this is the solid part. Okay, this is the solid part, and this is the void part. Okay, so for the void, again, I'm just looking at this component right here. This is the void part. Okay, so and that's going to be an 8 by 4. Okay, all right, mind you, this void does not start until I've gone from my reference point all the way about 4 inches high, and that's why I have the 4 inches high right here. So in this case, you remember our centroid for a trapezoid is nothing more than y equals h over 3 2a plus b divided by a plus b. Okay, and when you do that, you're going to get, so for your trapezoid here, you're going to get, this is your trapezoid right here, you're going to get 5.67 inches. Okay, and then for your rectangle, for rectangle, right here, we know it's going to be h over 2, which is going to be 8 divided by 2, which is 4, plus this 4 distance that they had to travel from your reference line. This is your reference line right here. That gives it 8 inches. Okay, so that's y2, this is y1. Okay, so when you come now, so draw your table. You have a solid for number 1. This is number 1 right here. This is number 2 right here. Geometric shape 2. So for your solid, you have your area, which is the area for a trapezoid. When you look back at your formula sheet, it's typically going to be h over 2, a plus b. Okay, when you do that math, you're going to get 144. Okay, your y bar is 5.67. Y.67, 5.67. I'm sorry, and then the product of the two is going to give you 816. Okay, inches cubed. And now we want to look at the void part, which is this rectangle right here. Okay, that area is going to be 32, but you got to put a negative there. Why? Because it's a void. Okay, So now the centroidal distance was 8. And then when I multiply the two together, I'm going to get a negative 256. Okay? So when I create the summation part of this, I'm going to get 112 here. I do nothing to my distance, and I'm going to have 560 here. So my y bar equals the summation of the product of my area and this centroidal distance of each component, right, divided by the sum of the areas. Okay, it's going to be 560 divided by 112, and that's going to give me 560 divided by 112. That gives me 5 inches equals my y bar. Okay, so this y bar here equals 5 inches. Okay? And this is your answer. Okay, I hope this helps. I have quite a few exercise problems I'd like for you to work out. We did this. We did this as well. I would like for you to do number 3. This is going to be homework. Number 1. I would like for you to do number 4. Again, think of the triangle. Okay, from here to here is going to be your distance here. It's going to be your h over 3. Okay, so keep that in mind. From here to here is going to be h, and this is going to be h over 3. But now you got to calculate from here to here, though. From here to here. Okay, so keep that in mind. You got to calculate this portion. Okay, all right. So I want you to do number 2. I'd like for you to do number 3. And this is going to be your 4th one. Okay. So that's 4 questions that I would like for you to do. And again, these are your answers. This particular one doesn't have an answer, but here's an answer right here. Here's your answer right. I'm sorry. Oops. I'm not actually. That's on the previous sheet right here. Okay, so your answers are going to be here, and your answer is going to be here. Okay, so double check your answers, and then just have this turned into me, and then we can go in from there. Okay, I hope this helps. Thank you very much for your time and your patience. Thank you. If you have any questions, please let me know. Thank you. Bye-bye.